Excellent. So good afternoon, everybody. My name is James Gress. I'm the North America Advanced DevOps Center lead for Accenture out of the Tampa ATC. We put this group together to talk about all things DevOps. So welcome. I appreciate everyone joining. We're always looking for speakers. So if you ever want to speak at this event, please reach out and contact me. We'll get you set up. And especially if you have any good, great, interesting topics. Even if you're, from the area and kind of new to the space or getting into things, we're still interested in hearing about what Tampa is doing in the DevOps area. We also have DevOps Days Tampa Bay coming up in 2022. So if you're interested in being an organizer, we are short on organizers trying to get this thing up and off the ground. We do have some funding to get this thing kicked off properly for 2022. So if you're interested in helping out, we're just looking for organizers that can devote some time into helping us kind of shape what that thing looks like, be able to put other speakers together, as well as bring the vendors together, et cetera, and have a great second meeting following our inaugural 2019 event. However, the last couple of years, we've decided not to do them due to the pandemic that's out there, but we are interested in kind of kicking that back into gear for like early next year. This will be a recorded event and posted on YouTube. Some quick guidelines for the call. If you are, please stay on mute. Unless you're asking a question, feel free to unmute yourself, ask a question. Paul will take questions during and or after the session. At the end, we will open it up for questions, answer anything that you might have. You can also put them in the chat window and we'll get them answered. At the end of the meetup, we will be raffling off a $100 gift card courtesy of Windocks. And during this discussion today, we're going to be talking a lot about databases and how it relates to DevOps and how to consume those in an efficient and more modern way. This has been a challenge for a lot of organizations we've worked with or that I've seen in the last 27 years that I've been in the IT field, and doesn't look like we're going to necessarily solve that all that quickly, but with tools and techniques that's coming out of some of the new modern ways of doing things, we definitely can get a handle on that and start to mature it and start moving it along. So to talk about this stuff, Paul Stanton, the co-founder of Windocks, has been doing this for 5+ years in the database of how it relates to DevOps. And he's going to give us a presentation on some of these new modern ways of doing things, and looking forward to it. So Paul, if you want to take it away.
Thanks, James. I appreciate the intro and the opportunity to present here today. Let me get queued up properly. So can you see my screen at this point?
I can see it.
All right, very good. Well, thanks everyone for joining us today. Just to expand briefly on what James shared earlier, I'm a co-founder of a company called Windocks. We've focused on databases for DevOps for the past, 6+ years in actuality. As James and I were chatting before the session began, let's just say we were a little early to the market, but in the past 2 to 3 years, we're definitely seeing a growing business with a lot of success. What I have to share with you today is based on, broad range of experience working with automation with existing storage arrays, as well as some database virtualization technologies on Linux and Windows. And again, if you have any questions, please interject as we go. It's a relatively small group, so there's no reason we can't be interactive in our session today. Database for DevOps is problematic for nearly everyone today, simply because the tooling for database operations and automation has not advanced much in the past decade. What I see typically is a single test instance with a fixed set of databases, and the tests obviously have to queue up to be run. So it limits testing throughput If there is a test failure, things have to stop to examine the failure. After the tests are complete, on success, the databases oftentimes are returned to a pre-test state to resume testing. So it's kind of maintenance intensive. The environments that are being used in these test environments are typically out of date and oftentimes lack the type of rich synthetic test data that would make for a better testing environment. And then clearly, an environment that's built this way is not generally going to be useful for debugging a production database issue. So in short, I would say in most cases, enterprises really are not in a situation to pursue a proper DevOps process with their databases today. So today we're going to talk about some of the tooling involved in enabling databases to be managed as a proper DevOps artifact and that support delivery in a matter of seconds for automated testing pipelines and other needs. And the technologies that allow us to deliver these database environments quickly and efficiently fall into a term called database cloning. Others will call this database virtualization. And these are supported by storage arrays. Tier 1 storage arrays from NetApp or Pure Storage support this. But the ones that you'll most commonly hear about for DevOps will be systems like Cohesity, Actifio, Delphix is another company. And these are essentially secondary storage systems that provide database cloning. Now, database cloning also can be supported with standard file systems. On Linux, that would be typically ZFS, and with Windows, we're talking about virtual hard drives as Microsoft's standard file format that simulates a hard disk. These technologies, by the way, are essentially the same technologies used to deliver and support virtual machines as well. Get the same kind of cloning of a virtual machine from an image that delivers a writable environment. In the case of databases, clearly we're cloning databases in these environments. The clones are delivered in a matter of seconds. And on delivery, the clones occupy only about 40 megabytes. They're really an empty container with inode file pointers or the equivalent to the image for read data access. Writes in the clones are persisted with either a copy on write or a redirect on write from the image. So those clones will grow in size based on writes. An ETL process will grow a clone substantially. And these images can be updated through a variety of means to support near real-time reporting and analytics, as well as providing production environments for debug and support. In most cases for DevOps, updating an image to be near real-time is not particularly needed, but it certainly is there and it's available. These images can support either a single database or multiple databases in an image. I have customers that deliver a couple of dozen databases in a single image. That's not particularly common, but it's very doable. And you'll note that data masking, data quality, synthetic data, and other security and data engineering steps can be added into the image as it is built. And so the images here are either going to be captured through a ZFS clone or a snapshot of a storage array, or it can be built from backups. So backups, you can think of backups being restored into a ZFS or VHD image. And during that backup restore process, when that's complete, that's when you would typically apply your data masking, apply your data quality, synthetic data, and the like. And user and group level access controls are also applied to the images as well. Okay, so that's core technology. Now, the benefits of database cloning should be reasonably clear. Delivers these database environments in seconds, so you can actually keep up with an automated CI pipeline. there's no need for test database maintenance in this case, because when the tests are complete, you typically simply delete them and replace them. It's more efficient to create a new identical environment than to maintain an environment that's been cloned. These can be versioned proper DevOps artifacts. They also have some rich metadata associated with them, so they help contribute to an overall master data management strategy, a data hub, and the like. I think these are a good technology for data mesh as well, which is a growing topic. Database clones can support containers and Kubernetes, so you can support your cloud native environments with containers, but you can also support fixed instances, as we've already noted. The nice thing about this is that this can remove infrastructure dependencies beyond your Linux and Windows servers. And that leads us to the next topic, which is what are the options for database cloning or database virtualization? And those are really twofold. As I've already mentioned, there's a number of storage systems available that support database cloning, Actifio, Cohesity, Delphix, and others, as well as standard file systems that we'll also take a look at. Now, this is a bit of an eye chart, and I apologize for that, but I want to be complete and fair on the treatment of these things. Starting off, I would say an organization that has access to storage systems that deliver database cloning, I'd always recommend that they be used. So if you've got the systems, use them. It's only prudent. These systems do typically involve a staging server that is creating a production environment, kind of a mirrored production environment. The staging servers then provide the basis for snapshotting of the production database environment. That in turn can then be masked and create a golden copy for DevOps. These systems, storage systems, will typically involve a client side or agent that needs to be installed on the source machines as well as the targets. The pipelines will deliver the data to fixed instances. They don't generally support containers, at least not out of the box. And if you're looking to automate things with scripts, the scripts can be pretty complex. There's a number of steps involved in creating the clones and delivering them to your target instance. Clearly, if you have these systems, it's advantageous to use them. And that staging server, while it is an added complexity, it gives you near real-time synchronization with production. So it's a real benefit there. But at the same time, recognize that DevOps is, you're creating a very hard infrastructure dependency, which would not be considered a DevOps best practice. Again, you face that trade-off. If you have the systems, I would say use them, just recognize the dependencies you're creating. And this is not the sort of thing that can be easily evaluated. You can't go and get downloadable software, install it on a standard Linux machine, and evaluate this stuff. It's much more involved. You're going to have to work with your infrastructure team to get access to these systems. And but they do work, and they're proven and robust. So that's your option number one, is if you have existing storage-based available systems that support database cloning, these are the pros and cons. The alternative is to use standard Linux and Windows servers. On Linux, that'll typically involve the ZFS file system. On Windows, as I mentioned, it will be the virtual hard drives that are known for supporting Hyper-V VMs. In this case, I would recommend using a Dockerfile to organize the image. It does create a benefit of being configuration as code, so the entire environment can be defined by that plain text Dockerfile. It can build in the data masking, release scripts, data quality, and other data engineering steps that you want to build into these environments. These Docker files obviously are geared first and foremost for containers and Kubernetes, but the data environments can be served up equally well to conventional instances. So it's one of the few instances where a solution is not creating a technical silo, excuse me. And the data can be sourced from any infrastructure that you've got. A single API call will deliver the entire environment with your masking and git clone of a repo with release scripts. And the whole environment is delivered. It's a writable, complete database environment. There's no sharing involved, so you don't have to maintain or share instances. Pros, I think configuration as code is a big plus. The ability to use containers is also a big plus. I've got a pretty good sized business, and I would say 95% of my clients have migrated to using containers for database DevOps. They love it, and it's more efficient. Also, a benefit of containers is that you can generally reduce the VM count used in lower level database environments by a factor of 5, even 10 to 1. So there's huge savings to be realized, a great amount of efficiency to be realized with containers, generally speaking. And you can use any storage, so you can leverage commodity storage. This is a technology that can easily download and evaluate and deploy very quickly. So it's really geared for DevOps teams. On the downside, syncing with production is not as straightforward because you don't have that staging server that you would typically have with a storage system. But you can update environments with transaction logs, just not quite as easily and efficiently. And the HA and DR support is more limited in these use cases. Now, this configuration as code would typically be accomplished with a Dockerfile. And this is a simple Dockerfile here. You can see that you're always going to specify the target database environment. In this case, it could be Microsoft SQL 2019. You can build in image permissions for dev and test groups in this case. If you're working with backups, those will be specified. The path to the backups will be specified in the image. In this case, it's a couple of full backups with DB1 and DB2 as the named databases. And then those backups are going to be restored to the respective ZFS volume or the VHD disk. And once those are restored, then the data masking, data quality, synthetic data, and other data engineering processes will be run. And so you end up with a kind of a golden copy, if you will, of a database environment that's masked, that includes whatever the processes that you wanted to include. So it could be data quality again, or synthetic data. And these processes can support scripts, as I'm showing here, but also batch files and even executables. Now, another aspect of what you can do with a Docker file is you can separate the items that are done one time during the image build and the steps that you want to run at runtime. So when the database environment is being cloned from that image that's built above, you can do things like you can clone a Git repo, you can assign a Git branch, and you can run migration scripts. That's a very simple but very popular way for people to integrate a workflow like this to clone and run migration scripts on a containerized, virtualized database environment. So if you think about that for a moment, that's a way in which developers can share an image with testers, and they can run their migration scripts that are in a feature branch in the repo. Testing could be working with the same image, but work with a release branch and run their testing scripts. So a very easy way to integrate source control into the workflow and share an image for multiple functional teams. This all comes together, in a sense where you've got production data kind of being sourced from backups or other means. Could be an Aura data folder from a source database instance. That data can be brought in, restored into ZFS or VHD images, or it could be Cohesity or Actifio or other storage appliances. Masking would be run against those environments, and Git repos can be cloned and migration scripts run, and the whole thing can be orchestrated either by Jenkins or Azure DevOps or other orchestration systems. I've got a number of customers that use the same basic workflow with Kubernetes directly. And the environments then can be served up on demand. Testing can be run manually or automated pipelines. And as those tests pass, the environments would typically be deleted and you move on to the next test. Okay, so any data, any relational data, any NoSQL data, could be textual data, configuration files and the like, can be served up. You actually can build out a enterprise DevOps data repo that is a distributed cross-platform repo with a centralized management plane and API service. And I've been at this for a number of years, so I'm going to continue on with some opinions. A couple of comments I'll make is that, I really recommend that data be managed adjacent to production. I see too many people needlessly copying production data from one location to the next. It serves little purpose from my point of view. Take the production data where it's located, put a appropriate DevOps supporting data server in that location and clone it and serve up those data environments. Use the secondary storage systems if you have them available. If not, avail yourself to standard database cloning on Linux and Windows. Runs great, provides very comparable service as available on these storage systems. For runtime environments, I would strongly encourage people to explore using containers. Dramatically simplifies your infrastructure, but don't implement containers in a fashion where it precludes the support of instances. Most organizations are going to need both, if nothing else, simply to migrate to a more modern environment with containers. High performers that I work with use Git with migration scripts over state-based source control. But the type of approach that I'm talking about today will work with both. It's not a blocking issue. In terms of orchestration, I'd suggest you align with whatever the standards or popular systems are within the organization. And in terms of database cloning itself, which is just one piece of this equation, again, you can use those secondary storage systems when they're available. Just be aware of the trade-offs involved. And I would comment overall that all of this comes together at an enterprise scale. You're going to be dealing with a mixture of storage types, a broad range of data types. You're going to want to, generally speaking, you want to centralize your security policies and build the security into these data environments. And you should be embracing, cloud native infrastructure, going forward. DevOps today revolves largely around containers and Kubernetes. That clearly should be your long-term goal for data as well. I'm going to pause here just to solicit any questions because I'm going to move on now to a demo. Any questions at this point? You guys are letting me off easy today. That's fine. So can you see my screen now? James, can you confirm the screen?
I can see it.
Okay, very good. Okay, so this is an example now. This full disclosure, this is my software. This is Windocks running. This happens to be running on AWS. And this is actually a small 2-node cluster. I've got a Ubuntu VM hosting an Oracle image as well as Postgres. And then I've got the Windows server, which is actually what we're looking at here with a number of SQL Server images. And so this is a very simple case of a cross-platform distributed repo with a shared management plane and API service. Now, I've previously built these images, so I've restored, like I've got a SAM database in this new mask image. And what I'm going to do is I'm going to shift over. Now I'm on Azure DevOps, and I'm going to simply kick off a new pipeline. And the purpose of this is simply to illustrate that, you know, with RESTful API calls and the versioned images that we just looked at, these complex data environments can be served up. They're versioned. They can be served up on demand for a continuous integration testing process. And while this is not going to run quite as quickly as a Java or .NET app, it will run, you know, in a matter of seconds, as opposed to requiring hours or days to provision for testing. And when this is done, we'll have 2 separate stages of testing pipeline will have been completed. This image is provisioning SQL Server 2016 containers with the database. The database is masked, and we're running some test scripts against this environment as it's being delivered. So you can think of this as being a, you know, a simple 2-stage pipeline. Think of it in terms of an integration testing and perhaps, you know, some additional integration testing that's being run. Now, normally when this pipeline completes, if the tests pass, the environments would simply be deleted and replaced with, you know, additional environments for the next round of testing. Now, this pipeline is running against the same VM that we just looked at. And so a single VM can be supporting developers and testers that are manually provisioning environments. At the same time, that single VM is also supporting the continuous integration pipeline. You can support either 20 or 50 or up to 100 simultaneous containerized database environments on a single VM. That high level of density is how people reduce their VM counts by a factor of 5 or 10 to 1. Most of my customers are actually netting a positive ROI by implementing a system like this, simply because they're consolidating, you know, so many different VMs. They're saving a lot on reduced VM maintenance. And while I've been yammering along, we're at the 2-minute mark. That first stage pipeline has already been completed. So now we're moving on to the second stage pipeline. And that will click along as well. And so this illustrates the whole notion of databases being managed as a versioned, secure DevOps artifact. We have a distributed repo that the pipelines are calling to serve up these environments. The connection strings are also being provided in a case where you've got the you know, Kubernetes hosted service or a full stack complex application that's being tested. It's easy to plumb up the back end to the front end for testing. And that is the bulk of my presentation. So this is going to finish up in a few seconds. We'll switch over to the server. We'll open up one of these containers, and you'll see that the environment was delivered just as we've talked about, fully automated pipeline. And so it looks like we're nearly done. So now's a good time to chime in with questions. Okay, so if I come over here and take a look at our runtime environments, looks like I need to log back in. You can see our testing and staging environments were provisioned. Let's go ahead and open up one real quick. Port 10,007. I'm going to go ahead and just use my local Windows auth to connect. I can also use SQL logins. And there's our database. So it illustrates the on-demand nature of databases. It illustrates the use of Dockerized container environments. This is a SQL Server container, but it's identical to a conventionally installed instance. So you get 100% compatibility with the SQL security model, SQL Server security model, and SQL Server tools, while at the same time delivering all the benefits of a fast, efficient Docker workflow. It's also notable that just this real-time view of all the database environments is not something most people have today. You know, people will have literally hundreds or even thousands of lower level database environments. This gives you a good handle on what's out there. You can begin to drill down to see what's being used. If it's not being used, you can blow it away because presumably people have saved their work and they can recreate it from their Git repo. That may not be always the case, but it's an exciting prospect. Okay, so that is the description. I really can't continue to yammer on unless there are some questions. So I'd really like to open it up for questions at this point, James.
Absolutely. So any questions out there, please feel free to put them in the chat or just unmute and ask directly. Happy to get those things answered.
Well, let me ask you a question, James. What are your questions or feedback based on what you see people doing in the marketplace?
Yeah, I still think people are kind of struggling in this area overall and trying to find decent solutions around it.
Yep.
You know, they're using a variety of different products out there in the marketplace. You know, this one is this is the first time I'm really kind of seeing this other than the time we talked before.
Right.
So just still trying to absorb this particular technology. Looks very powerful, especially with the use of containers and being able to spin things up very quickly, doing a virtualized environment where we're not, you know, increasing large databases over and over again, etc. So
yep.
I think that overall, I mean, these are the types of things people need to start thinking about as we start to integrate, especially in with integration testing, performance testing, etc.,
yep.
within the pipelines to be able to have reliability and resiliency through our pipelines.
Yeah, yeah. I'll say that, you know, in my business, I don't have a sales force. We meet with people online. They download our software, they get it installed. We support pilots generally in 2 to 4 weeks working part-time. Implementations can be completed. Users can be brought on board. And over the past 2 years, I've had 90 to 95% of the customers that have evaluated our software have become customers. So it really speaks to product works as advertised. This is not complex to implement. Building, you know, these images, you know, we took a look at the Docker files. This is really the only aspect of Docker that people need to understand is just simply this plain text configuration file that spells out what you want to do. So people are generally pretty comfortable with, you know, a configuration file like this. You submit this along with the backups, the paths to the backups, and this masking, and the images get built. And then once the images are built, you know, as we see, delivering them becomes a piece of cake. And I really encourage people to kick the tires if you are interested, because it does work very, very well. Got customers all over the world doing this at scale today, and they're happy as clams.
Excellent. So Paul, why don't we do this? Well, we'll end the recording part of it and then go into the raffle part and see if anybody wants to ask any questions after we kind of stop the recording and whatnot.
All right, sounds good.
Just definitely wanted to thank you for speaking at this event. Very great presentation. I appreciate it. Thanks for the time and everything that you've done here today.
Yeah, it's my pleasure, James.
So what I'm going to do is I'm going to stop the recording.